So this quiz here had a little bit of lesson 3, the elevator question, but we started out just with the concept of F equals ma. Hey, let's add good old Ann. What is the definition of a force? I said a force was a push or a pull. Was that Aiden dropping something again? Because that would be funny if it was. Oh, wasn't you this time? Okay. What is the unit of force? Or kilogram meter per second squared. Because if F equals ma, then it has to be ma. We used to write kilogram meters per second squared as our unit of force, and then they decided, let's give that unit a name and a symbol of its own. We're sick of writing that out, the Newton. You could also, definition of force, you could have said mass times acceleration. I would live with that. Anybody else say anything else? Okay. So 1 mark for the definition, 1 mark for the unit of force. What net force? And so Deegan and Riley, what we said as a trigger word, whenever you see the word net force, you can jump straight to F equals ma. You don't need to go free body diagram. That's my way of saying I've done that for you. Here, they want me to find the net force. It's going to be 1,200 times 2, 3,600 newtons of force. Yes? No, 2,400. Wow, Duick. Newtons of force. Yes? Number 3, 3 marks suggests I'm going to have to find something in order to find something. But again, it says net force. They want the net force. I said F equals ma. I did a quick check. They gave me m. They didn't give me a. I said, okay. I'm going to need to fill in that blank. VI 0, starting at rest. VF 770, about twice the speed of sound, a little more than twice the speed of sound. Looks like the distance it's traveling is 1.5 meters. I think I can use A equals VF squared minus VI squared all over 2D. Is that correct? And I think it's going to be 770 squared minus 0 squared all over 2 times 1.5. Is this bullet speeding up? Is this a cannon? Artillery shell. Is this artillery shell speeding up or slowing down while it's in the barrel? Am I expecting a positive or a negative acceleration? Okay. I probably didn't need to type the minus 0 squared. And I get 197633, big number. At first, I started to get nervous, but then I went, wait a minute, this is an artillery shell. Yeah, there should be a big acceleration. So I'm okay with that. So I wrote 197 and 3 zeros, but I'm going to use my answer button. In fact, I wrote 198 and 3 zeros, but I'm just going to use my answer button. So the net force is going to be 65 times 198,000, but of course I'm using my answer button. 65 times answer button, and I get that. I'm going to write that in scientific notation because it's less work. 1.28 times 10 to the 2, 3, 4, 5, 6, 7. Or if you wrote it out the long way to 3 sig figs, it would be 128 and then 5 more zeros, I think. Whatever. Newtons. Yep. But you did extra work. By the way, is this artillery shell packing a lot of force? Yeah. When it hits a target, will it do some damage? Yeah. Now, it probably won't apply that big a force when it hits the target because it'll probably take longer than 1.5 meters to bring it to a stop, but it will come to a stop if you knew how big a hole it made upon impact. You could calculate the net force it applied, the average force that it applied. Not good to get hit by an artillery shell. If you got that 3 out of 3, otherwise I would probably give you a half mark if I saw that. I would give you 1 mark if I saw that. I would give you a half mark for the acceleration and give you 1 mark for the answer. That works. Number 4, I'm going to use Kiana's law. Why don't I need to do a free body diagram? Because Deegan had said net force. So it's going to be 12 divided by 1.210 meters per second squared. Yes? Almost exactly a G. Tiny bit more than a G. 1 mark. Number 5, they want the average acceleration. I really quickly noticed I saw time and I saw speeds. I said, I'm going to use my DFIC approach where it looks like we have from rest. It looks like VF equals 3.2 times 10 to the 4th. T equals 32. I know they give me a mass. I don't think I need the mass to do this part. I think it's going to be A equals VF minus VI over T. It's going to be 3.2 times 10 to the 4th minus 0. Am I going to bother entering the fact? Really, I probably could have just left that off, but I'll put it there because some of you still like it. Divided by 32. Oh, this works out evenly. Is it 10 to the 4th, right? No, 10 to the 3rd. 3.2, yeah. Is it 1,000 even? Or am I wrong? Yeah. Okay, 1 mark. What's the average net force? Oh, they said net force. I can go straight to F equals MA. So it's going to be 4.5 times 10 to the 4th times 1,000, which is going to be 4.5 times 10 to the 7th newtons, or a 4, a 5, and 6 zeros after the 5. Pretty sure. Let me know if I'm wrong, because I did that one in my head.
Right.
Okay. Ooh, how far? Okay. From rest, VI is 0, VF Peniel 12, yes? What else do I need to find a distance? Ah, I said I need to fill in that blank. Gotcha. Oh, I can use Kiana's law, A equals F over M, because we have 1.6 newtons divided by 6.4 kilograms. The acceleration is 0.25 meters per second squared. I said, cool. D equals VF squared minus VI squared all over 2A. 12 squared minus 0 squared all over 2 times 0.25. I can do this in my head. 12 squared is 144 divided by 2 is going to be, oh, divided by, you know what, Mr. Duick? Why don't you just do that? Is it 244? No? I'm wrong? Good gosh, 12 squared is 144 divided by 2 is going to be 72. 72 divided by 0.25 is going to be 72 times 4. So it's going to be, oh, I was wrong, 288. Duick. And that's meters. 3 out of 3 if you got that. Otherwise, I would probably give you 1 mark if I saw that equation, half mark for the answer, 1 mark if I saw that equation, half mark for the acceleration. So I would probably give you half mark for that and a half mark for that. Thank you. How much time? And you're right, Annika said, Mr. Duick, why is this 2 marks? Because technically you did have to rearrange an equation and use some stuff from a previous answer. I chose to go with T equals VF minus VI over A. You could also have gone T equals the square root of 2 times D over A using your answer from part A. You could also have gone T equals 2 times D all over VI plus VF. I think all of those would work. This one I think is the laziest way to get the easiest equation to rewrite. So it's going to be VF 12 minus 0 divided by 0.25. Did you get 48 seconds? So I would give you for all of these 1 mark for the equation, 1 mark for the answer. But I'm willing to bet most of you avoided those two. They work? A book is sitting on a level desk. Which of the following statements are true? True or false? There are no forces acting on the book since it's not accelerating. True or false? Oh, what forces are acting on it? Oh, but since it's not accelerating, that tells me not that there's no force, but that the forces must be. I'm looking for the letter B. Ah, okay. Oh, go with red, Mr. Duke. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force. That, I think, is true. That's why it's not accelerating. The net force on the book is equal to 0. That's true. That's really what Newton's first law says. If you're not accelerating, your net force must be 0. Friction is what's holding the book on the desk. My go-to whenever you ask me a friction question is I imagine ice and Velcro. If your desk was made of ice, could the book still stay there as long as the desk was level? So friction is not what's holding the book on the desk. I like number 8. I like number 8, number 8. There's going to be an elevator question on your test. Okay? First of all, did you notice I gave you the weight, not the mass? This person does not weigh 588 kilograms. That'd be a lot. We're accelerating up. This is a job for a free body diagram. What are the forces acting on this person? Get the obvious one, mg. What else? Well, the floor must be pushing up through their feet, and because they're accelerating up, that must be winning. In fact, my equation is going to be winner minus loser equals ma. They want me to find the scale reading? No, they don't. What do they really want me to find whenever I ask for a scale reading? Fn. Yep. Maybe. Well, have I told you that I'm lazy but organized? You don't realize just how lazy but organized I am. Patience. First of all, how would I get the Fn by itself? This is not the swappy dance technically, because the Fn stays where it is. So I am so lazy. Here's what I did, Aiden. I said, I'm not going to bother calculating the mass. I'm too lazy for that. I know mg is 588. I know the mass is 588 over 9.8. That's what I typed into my calculator. And I'll show you why as well, because I'd also read to question 2, and you will now see exactly how lazy I can be. So I went 588 plus 588 divided by 9.8 times 1.2. I said the scale will read 660 newtons, which is correct. If you got that 2 out of 2, otherwise I would give you 1 mark for that, half mark for getting the normal force by itself, and a half mark for the answer. If you treated the 588 as kilograms, I'll show you what you would have got there shortly. But for now, I got to B, and I said, I wonder if I can imagine a new free body diagram in my head. If we're accelerating downwards, which arrow here would be longer? Who would be winning? So I went like this. mg minus Fn equals ma. I did the swappy dance here. Aiden, I got Fn equals mg minus ma. And I said, okay, that's going to be 588 minus 588 over 9.8 times 2.25. See, Aiden, this is how lazy I am. I said, I can bring back my previous line on my calculator, and all I need to do is change the plus sign to a minus sign and change the 1.2 to a 2.25, and I don't need to retype anything. I do actually think about these things. So that's why I chose not to bother. Also, by the way, if you go 588 divided by 9.8, oh, this one did work out evenly. Often it's a yucky decimal, and I would rather use my answer button or just put it in there rather than use a rounded off mass. Okay? What did I get? 453. newtons. By the way, again, for number one, if you treated that 588 as though it was kilograms, you would have gone 588 times 9.8 because you wouldn't have realized that it was mg, and then you would have gone plus 588 times 1.2. If you got 6,468, I would give you 1 out of 2. And for B, again, if you treated it like kilograms, you would have gone 588 times 9.8 minus 588 times 2.25. And if you got 3,969, I would give you 1 out of 2. What's that tell me? What if I was moving down at a constant velocity? Same question. Same. Albert Einstein, we'll talk about it when we look at relativity, but he profoundly said, we can't tell if we're moving at a constant speed or at rest. We can only detect acceleration, but there's no experiment in the universe that can detect moving at a constant velocity. Yeah.
Does that mean if you could be in an elevator that's falling at its terminal velocity?
Yes, absolutely correct. Yep. Or you could be in an elevator that was at rest. You couldn't tell. Yep. Yep, I agree with you. Meanwhile, it's a tie. So you could go like this. Winner minus loser equals MA. And then you could say, hey, I know that A is 0. And then you could plus the normal force over. Or you could have just said, hey, it's a tie. Because it is. So I'm pretty sure the normal force equals 588 newtons. Yes? Sorry, I don't know if I answered you correctly. If the elevator was in free fall, you could tell that because you'd be floating. But you couldn't tell the difference between an elevator on the Earth in free fall and being in outer space with no gravity. This was, Einstein called that the happiest thought he ever had. That was his aha moment to figure out general relativity. We'll talk about that. Hopefully you all said 0? Yeah. You'd feel weightless. Are you weightless? Gravity's still there. You're apparently weightless. 2 marks. Can you give yourself a lovely score, please, out of 23?